It's my great pleasure to have a few comments to say about Qi. Qi is a graduate of Peking University. She got her bachelor's degree in chemistry at Peking University. It's not unusual for our chemical engineering graduates who do research in the department to have degrees from other departments. Chemistry is fairly common. But what Qi did when she came here was to be in the chemistry department, which is about 300 yards from here, for a year, and then decided she really wanted to be a chemical engineer. So she officially transferred programs and then joined my group. Now I actually met Qi before she came to Stanford. I was attending the 50th anniversary of the Polymer Science Department at Peking University. And the foreign visitors were each assigned a student host. And Qi was my host. Now, there was some discussion, I suppose, prior to having these foreign visitors about whether they could pronounce the names of the students. And so at that time, Qi had a different name, okay, that she was using, and we got along fine with that, and then we got along fine with the name when she came here. She's been involved in a wonderful collaboration with two faculty groups from the Civil and Environmental Engineering Department. One of these group members is a microbiologist or a biochemical engineer. He has identified a series of bacteria that can take methane, which is a global greenhouse gas, and turn that methane using microbes into a plastic. Now, this is not a new phenomenon. It's been known for 4 decades at least. But what is novel is the use of methane as the feedstock. And prior to that, it was glucose. Glucose is an expensive material, and it could be used better for other purposes. Well, in this collaboration, we are using the methane to produce, or actually to feed these bugs. The bugs make the plastic. My group's responsibility and Qi's responsibility is in working with that plastic. We extract it from the biomass. We make composite materials with it. In fact, what Qi's been doing is to work on a whole series of experiments with plastics like the ones produced by this biomass. We don't have enough of it yet to actually work with it in the lab. But she's worked with it in the solid state, in the molten state, and she's made foams out of these materials. They're of interest because they're biodegradable. So you can have a fermentation process to create the plastic. You use it in a construction project, maybe for formwork, for concrete. After that's done, you throw it in the landfill. It decomposes back to methane. Full cycle. And so it's a good example of green chemistry. Qi has been a wonderful member of my group. And she's actually doing something that administratively is called a walkthrough, because she has a minor administrative detail that she hasn't passed her oral exam yet, but that's Monday. And so wish her luck on Monday, and let me congratulate Qi.
Paul William Lust.